standard deviations around that sample mean we got. It's actually 4 standard deviations, but it's plus or minus 2 standard deviations. No, we would no, not at all. Not always. Just for today. Create an interval around the sample mean and say that the population mean should be within a specific interval. That the interval be plus or minus 2 standard deviations. And let's see why we're going to use 2 standard deviations. If I think back to my normal distribution, I think my mean here, here's plus 1 standard deviation, here's plus 2 standard deviations, minus 1, minus 2 standard deviations. Do you remember what percentage of the area under the normal distribution is between minus 2 standard deviations from the mean and plus 2 standard deviations? So that's pretty good. That's the only part of the empirical rule I remember is the 95. The rest of it, Alright. Alright. So that's 2 standard. So that gives me 2 standard deviations. If I'm covering 95% of the normal distribution, I let myself be 95% confident. No statistician is ever 100% confident about anything. But it's okay to be 95% confident. Sometimes you can be a little more, sometimes you can be a little less. But we'll do 95% confident. It's pretty common. 90% confident is pretty common. 98% confident is pretty common. Okay? Now, within these 2 standard deviations from the mean, 95% of the sample means will be in this interval. Mean plus or minus 2 standard deviations. Okay, so let's build a confidence interval. Now in the example I'm going to give you today, we're going to know the population mean and standard deviation, but usually you don't know the population mean and standard deviation. That's why you go get a sample to estimate it. Okay, but I'll show you what will happen if we know. Okay, so let's suppose the average word length of your textbook is 5 letters. And we know that the standard deviation is 0.25. Now, since this book is on computer, you can have a computer go through and count the word up and average the word length. But let's just say, yeah, we're not going to do that. This is the old days where everything was typeset. And you're going to go out and you're going to get a sample of 100 words from your book. Now, the sampling distribution is every single possible sample of 100 words. And you're just going to get one of those samples for right now. We'll go get another one in a minute. Let's describe the sampling distribution. And we rarely use the word normal without using the word approximately in front of it, just in case. You know, you'll never go wrong by putting approximately or about. All right, so it's approximately normal. What is the center? Yes. The center of the sampling distribution is 5. And what is the standard deviation? The spread? Yeah, so it's 0.25 divided by the square root of 100 is 0.025. Okay, so let's draw this sampling distribution. There's a 5 in the middle. I'm going to put 1, 2, 3 standard deviations above, 1, 2, 3 below. One standard deviation above would be 5.025. 2 standard deviations above would be 5.05. 1 standard deviation below is 4.975. 2 standard deviations below is 4.95. You can put the other numbers on if you wish. Okay. About what? About 95% of the samples will be between what? That's letters per word. You won't after a while, just kind of for today. We'll get more exact, so you won't have to like remember the 95s and stuff. We'll get it. It's actually 1.960, and instead of 2 standard deviations for 95%. So but we're just kind of estimating for today. Okay. So let's go out and let's get a sample. And let's say that your sample has a mean of 5.01. Okay? I'm going to mark that on my drawing. 5.01 is going to be, let me mark that in a different color here. There's 5.01 approximately. Now remember, as a statistician, I don't want to report a mistake, so I won't say that the average word length in this book is 5.01 letters. I'll say 5.01 plus or minus a margin of error. So my interval, called my confidence interval, come on. Oh, just a second. It'll be back. Is going to be 2 standard deviations above and below my sample. I didn't mean to put a minus on my sample. There we go. So my confidence interval is going to be 5.01 plus or minus 2 times the standard deviation of 0.025, which happens to be 4.96 to 5.06, or you can write confidence intervals like this, 4.96 comma 5.06 in parentheses. That's why your calculator will report them. Okay? So I'm going to make myself on my graph here where 4.96 to 5.06 would be. So let me just do that with my little highlighter. 4.96, 5.06. Oh, I went too far. I went too far. Way too far. Jeez. 4.96. Yeah, I had to make that up. All right. That looks good. Does my interval contain the true population proportion? The true population proportion is 5 words, an average of 5 letters per word. I have reported that